we'll be talking about different types of probability. Let E be the number of goals in a football match scored by Team E against Team G. Let G be the number of goals in a match scored by Team G against Team E. The joint probabilities of E and G is given by this table. A. What kind of distribution is displayed in the table? B. What's the probability of Team E and Team G scoring no goals? C. Confirm the probabilities in the table add to 1, and would the probabilities in such tables always sum to 1? D. What's the probability of Team E scoring more than one goal in a match against Team G? E. Find the marginal distribution of G. F. Find the conditional distribution of E given G is 0. Let's focus on the jargon used. We've got joint probabilities, marginal distribution, conditional distribution. To explain those phrases, let's look at something called Bayes' law, otherwise known as Bayes' theorem or Bayes' rule. It says we have two events, A and B. This says probability of A given B is equal to probability of A and B divided by probability of B. And it exists so long as this probability of B is bigger than 0, because we cannot divide by 0. Now this here is called the conditional probability. As the name suggests, it's because we're interested in one event given or conditioned on another event that has occurred. An example of that would be, what's the probability that an email is spam given that it contains the message contains the word casino and prizes? Probability of A and B, that is called joint probability. As the name suggests, we're interested in the probability of more than one event happening. This one here, probability of B, is called the marginal or unconditional probability. It's the opposite of the conditional. The probability of B, we're interested in B occurring irrespective of whether A happens or not. So when we use the word marginal or unconditional probability, we are considering this event as one event of a subset of events. So Bayes' law links conditional probability to joint and to marginal. Say A and B are discrete, then a table consisting of the outcomes of A and B along with the associated joint probabilities will be called the joint distribution. A table of the outcomes of A given B and the associated probabilities will be called the conditional distribution. And the table of the outcomes of B along with the associated probability of B will be called the marginal or unconditional distribution. Now back to the question. So look at the table here and look at part A. What kind of distribution is displayed in the table? Well, we have G here, the outcome is 0 and 1. E, the outcome is 0 and 1. And in the table here we have the probabilities. So this one corresponds to joint distribution. It's the joint distribution because these probabilities in these cells denote the probability of a joint event happening. So B, what's the probability Team E and Team G scores no goals? That's like probability of E equals 0 and G equals 0. That is a joint probability. To get that, G is 0, E is 0. Look at the cell, probability is 0.6. So the answer is 0.6. Likewise, I could have asked, what's the joint probability that E equals 1 and G equals 1? Well, G equals 1, E equals 1 intersect here, so the probability is 0.1. Confirm the probabilities in the table add to 1. Clearly they do. Would this always be the case? Yes, because we know that probabilities add to 1. By adding to 1, I mean it adds to 1 if we add up the probabilities of all possible outcomes that we know it must come to 1. This leads us on to D. What's the probability of Team E scoring more than one goal in the match? Well, since this adds to 1, it must mean that with the goal scored, it's always got to be one of these four combinations. So what's the probability that E is bigger than 1? It's 0. Likewise for G, probability of G bigger than 1 is 0. If that wasn't the case, we would have to have extra cells here. And those cells would contain the probabilities of those events happening. E. Find the marginal distribution of G. So as we explained, this means that we have to write down the outcomes of G, which we know is 0 and 1, and the associated probabilities of those outcomes. And that's irrespective of what else happens. So in this case, irrespective of how many goals Team E scores. We can obtain the marginal distributions from the table of the joint distribution. So from joint we can obtain the marginal, and this is how to do it. First of all, for the marginal distribution of G, write down the possible outcomes. Well, we know that G can be 0 or 1, so we write down 0 or 1. Now we have to calculate the chances of these happening. Well, this one, what's the chance that G is 0, irrespective of what E is? Well, G is 0, irrespective of what E is, if we add up across outcomes of E, given that G is 0. So here we have G is 0 and E is 0. Here we have E is 1 and G is 0. So what we do is we look at this 0 and just add along there. So 0.6 plus 0.1, 0.7. Likewise, when G is 1, when is G 1? It's 1 and E can be 0 and E can be 1. So we just add along those probabilities as well. So that's 0.3. To check we've got the right answer, we add up the probabilities in our marginal distribution. Those probabilities must add up to 1. Sum to 1. Likewise, the marginal distribution of E can be obtained from this joint. When E is 0, G can be 0 or 1. We just add up this time across the rows. 0.6 plus 0.2, 0.8. When E is 1 is 0.1 plus 0.1, 0.2. Those two add up to 1. Done. Okay. Finally, we want the probability, conditional probability of E given that G is 0. Now, here is the table we need to complete. Probability, the distribution table. E given that G is 0. Well, when G is 0, we know that E can be 0 or 1. So we write down the outcomes. And then we have to calculate the probabilities. So we have to complete this table. Now, we can get the probabilities by using both the joint distribution and also the marginal distribution of G. First, I'll talk about how to get the probability of E is 0 given G is 0. probability that E is 0 given that G is 0. Now, because this is a conditional probability, we know the conditional probability is related to the marginal and to the joint probability through Bayes, like so. But we know what these probabilities are, because from the table, this top one, probability of E0 and G0, we get that from the joint distribution. E is 0, G is 0, that's a probability of 0.6. How about the probability at G is 0? We get that from the marginal distribution of G. G is 0 with probability of 0.7. And that comes to 0.857, 3 decimal places. Likewise, probability that E is 1 given that G is 0, we compute using Bayes, and that is equal to probability that E is 1 and G is 0 divided by probability that G is 0. Obtaining the joint and the marginal from the respective tables, we have 0.1 divided by 0.7, which is 0.143 to 3 decimal places. So here we have it, the conditional distribution of E given that G is 0. Check that these probabilities add to 1. They do, so I'm done. So I think there's quite a lot here, so you might wish to look at parts of this video again. If you want to see more of materials, you can visit us at statisticsmentor.com. And if you'd like to discuss this problem, click on the link given in the YouTube page, and that's below.